This is Activity 3, Comparing Volumes from Lesson 7, Connecting Representations of Functions from Unit 5, Functions and Volume. In this activity, you're to compare the volume of a cube to the volume of a sphere. And to calculate the volume of a cube, you can take the length of the edge and use that as a factor 3 times. So it's the length of the edge cubed. So if the edge is labeled as S, then it would be S times S times S. That's going to give you the volume of the cube. And the volume of the sphere, we're going to use this graph. And so down here along the x-axis, this is the radius of the sphere. And then you read along the radius of the sphere, and you read up to the graph, and then you read over to figure out what the volume of that sphere is given the radius. So in the first problem, it says the volume of a cube with an edge length S equals 3. Is that greater or less than the volume of a sphere with a radius of 3? So there's a little picture of what that looks like. So here's a sphere, and inside that sphere is the cube. The cube has a length along the edge of 3 units, and the sphere has a radius of those same 3 units. And you actually can see from this drawing that the volume of the cube will be much less than the volume of the sphere because it fits inside that sphere. To figure out the volume of the sphere, we can use this graph. So the radius of the sphere is 3 units. So you go over here to radius. There's the radius right there of 3 units. And you read up to the graph and then read directly over to the y-axis, which is the volume. So the volume of that sphere is 113 cubic units. And I should label this sphere right here as a radius of 3 units. And so then the volume of the cube is the length of this edge times itself 3 times. So it's 3 times 3 is 9. 3 times 9 is 27. So that's cubed. 3 cubed is 27 cubic units. And so once again, you see that the volume of the cube is much less than the volume of the sphere. And as a matter of fact, the volume of that sphere is approximately 4 times, it's just a little bit more than 4 times the volume of the cube. So the volume of the cube is 27 cubic units. 4 times 27 is 108 total cubic units. That's a little bit less than the volume of the sphere, which is 113 cubic units. So we'll come back to this relationship a little bit later. What's the volume when the radius of the sphere is the same as the length of the edge of a cube? How are those two volumes related? For problem number 2, it's a slightly different question. So the sphere and the cube have the same volume, and the edge length of the cube is 5 units long, and so they want you to estimate what the radius of the sphere is. So how do you start this? Where do you begin? So again, the same volume. The edge length of the cube is 5 units. So what's the radius of that sphere? So the edge length of this cube is 5 units. The two volumes are the same. So what's the radius of this sphere? Well, if we know the edge length, then we can calculate the volume of this cube. It's 5 cubed. 5 times 5 times 5 equals 125 cubic units. So now we know that the volume of the cube is 125 cubic units, and we can use that to figure out what the radius of the sphere is, because the volume of the sphere is approximately 125 cubic units. Actually, it's given as 125 cubic units. So the volume of the sphere is 125 cubic units. So you just go over to the graph. The y-axis now is 125 cubic units for the volume. And now we read backwards. We start with the y-axis. We're going to read over to the graph and then read down, and that's going to tell us what the radius of that sphere is. So the radius of the sphere is approximately 3 1/10 units. So approximately 3 1/10, approximately 3 1/10. So this radius is 3 1/10 units. And so the thinking was that if I know the length of the edge of the cube, I can figure out the volume of that cube. And this sphere has that same volume, 125 cubic units. And so I can use that 125 cubic units of the sphere, use the graph, and get an answer of 3 1/10 units for the radius. And for the last problem, it says compare the outputs of the two volume functions when the inputs are 2. So what's going into the system, what you're given as information, is that the radius of the sphere is 2 units and the length of the edge is 2 units. So this is very similar to problem number 1. It's just using 2 units instead of 3 units. But what they want you to do is get used to the language. The input is 2 units. What's the output? The output's the volume in each case. So what are you going to calculate? What do you want to know? And that's called a function. The volume is a function of the radius, or a function of the length of the edge. So for the volume of the sphere, we know that the radius is 2 units. So that's the input. It's also called the independent variable. And so that radius is 2 units, and we're going to read up to the graph and then read over, and that's going to tell us what the output is. That's known as the dependent variable, or the output. And so that output is 35 cubic units. So from the graph, the volume of the sphere is approximately 35 cubic units. And from the edge length, the volume of the cube is 8 cubic units. 2 cubed. 2 times 2 times 2. That's the same, by the way, as 2 to the 3rd power. And again, you see that the volume of the sphere is a tiny bit more than 4 times the volume of the cube. So the volume of the cube is 8 cubic units. 4 times 8 is 32. And the volume of the sphere is a tiny bit more than 32, or 35 cubic units. So this is happening when the radius of the sphere is the same as the length of the edge of the cube. I can add that information about the cube to this graph. So that's what this very thin orange graph is here. So if the cube has an edge length of 2 units, then it's going to have a volume of 8. 2 times 2 is 4. 2 times 4 is 8. If the cube has a length of edge of 3 units, it's going to have a volume of 27 cubic units. So 3 times 3 is 9. 3 times 9 is 27. And 4, if the length of the edge is 4 units, 4 times 4 is 16. 4 times 16 is 64 cubic units. And so you'll see that when the length of the edge is the same as the radius of the sphere, the volume of that sphere is a little bit more than 4 times. So this is 1 times, 2 times, 3 times, 4 times. If you go over here to 3 units for the radius and 3 units for the length of the edge, the volume of the sphere is going to be a little bit more than 4 times. 1 time, 2 times, 3 times, 4 times. And again, it's the same if the lengths are 4 units. So 4 units for the radius, 4 units for the length of the edge. The volume of the sphere is going to be a little bit more than 4 times. This is 1 time, 2 times, 3 times, and 4 times. So you're going to come back to this in lesson 20, I think. I'm not sure what direction the authors will take, but lesson 20 is on the volume of spheres.